Alright, so this video we're going to take a look at functions. It's kind of a lengthy video, but there's a lot in here, so let's go ahead and get started. So it says a function is a rule that assigns each element in one set to a unique element in a second set. And then we have a function as a set of ordered pairs. It says a function is a set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinates. So I'm going to talk a little more about these definitions when we while we're working the examples. I'll explain them more while we're working the examples, and I think they'll make more sense like that. But this second one here, that a function is a set of ordered pairs, it says in which no two ordered pairs have the same first coordinate and different second coordinates. What that means is you cannot have the same x value with two different y values. Okay, and so let's look at this example here, and I think that this will clear it up. So they want us to determine if the relation represents a function. So for this one, the 1, 3, 2, 3, and 4, 9. So we've got a set of ordered pairs, and this one is a function because we don't have the same x value with two different y values. And so that would make this one a function. Now, if that does not make sense to you, just bear with me while we work this next example, and after you see this next example worked, the first one will make sense, and I think it'll clear everything up. All right, so the first one is a function. Now let's look at this second one here. So we've got this set of ordered pairs. So remember, you cannot have the same x value with two different y values. So if you look at this, notice this point and this point here. See how we have the same x value and it's with two different y values? That means it's not a function. Okay, that's not a function because we have the same x, the 9s, are associated with two different x values. So that means it's not a function. Now, let's go back to the first one. Do you see in this problem, you see the x values? Do you see we don't have the same x value anywhere? Okay, none of the points have the same x value. So there's no way we can have the same x value with two different y values. So that makes it a function. All right. All right, so hopefully that cleared it up. All right. Now, that's if we have a set of ordered pairs, how we can determine if it's a function or not a function. Now, what if we have a graph? Okay, well, we can also determine if a function, if we have a function from its graph. So a graph is the graph of a function if and only if there is no vertical line that crosses the graph more than once. So in other words, if you draw a vertical line, anywhere you draw a vertical line through a graph, if it intersects that graph in more than one point, that means it's not a function. So let's look at the example. Determine which of the graphs are graphs of functions. So for problem A, this is not a function. Okay, because look, if we draw a vertical line, do you see how it intersects the graph here and here? It intersects that graph in more than one point. So that means it's not a function. Now let's look at B. Well, look at this. Anywhere we draw a vertical line, you can draw a vertical line anywhere. Okay, I'll just draw a couple of them somewhere. But look, no matter where I draw my vertical line, it only intersects the graphs in one point. It only intersects the graph at one point. It will never intersect this graph. A vertical line will never intersect this graph in more than one point, so that means it is a function. Okay. Now what about the next one, C? Well, look at this. You see the vertical line I've drawn? It intersects the graph in two different places. So that means this is not a function. All right. So what we've done so far is we've had a set of ordered pairs. So you can't have the same x coordinate with two different y coordinates. And then we've had graphs. Okay? And that's two ways that we can tell if something represents a function or not. Now, going back to the first problem we worked, remember, you can't have the same x value with two different y values. Well, you can see that here on this graph. You see this line here, it has the same x value. See, remember the x value moves left and right. So here's the x value, and this x value is associated with this point and this point. Actually, it has a bunch of, all the y values are associated with this one x value. So you can see it's more than one y value associated with this x value. And so it's not a function. But just remember the vertical line test. If it intersects the graph more than once, then that means it's not a function. Now there's something later on in another lesson, the video on inverses, that we'll look at a horizontal line test. What if a horizontal line crosses a graph more than once? Okay, but that's later on. All right, so we've done the ordered pairs, we've done the graphs. Now, what if they just come out and give us a function? Okay, so determine whether each equation defines y as a function of x. Okay, so first, let's take a look at this problem. All right, so we need to problem A, the absolute value of y equals x. So we want to determine if this is a function or not. Okay. All right. So these are a little more difficult to do. Okay. They're a little more difficult. And one thing about this is if you can picture what the graph looks like, okay, if you can picture what the graph looks like, it makes it a lot easier. You don't have to go through what I'm fixing to do. But as far as this one, I mean, probably at this point in college algebra, you don't know what this graph looks like. But I know what it looks like. It looks like this. That's the graph of it. So I already know this is not a function. Okay. So what if you didn't know that? Okay. So what you have to do is just kind of select some numbers. Okay. So if I say, okay, let's select x to equal 1. Okay, let's let x equal 1. So what all can I plug in for y so that I get 1 as an answer? Well, if y is equal to 1, then we know the absolute value of 1 is 1. And if y equals -1, then the absolute value of -1 is 1. Okay? So, in other words, if I take 1, let me do that. I guess I'll do it right here. So, if I take 1 and I plug it into this equation, I get x equal 1, right? And if I take -1 and I plug it into this equation, I get 1 equals x. So this and this, okay? So up here, remember I plugged 1 in for y. So that's the point where y is 1, and what did I get for x? I got 1. And then I got the point, well, what did I plug in for y? I plugged in -1, right? And what did I get for x? I got 1. So you see here how I have the same x value with two different y values. So that means this is not a function. Okay, and like I said, this is a little more complicated. It's a little tougher to determine if these are functions or not. Okay, when you just have when they give you the equation. Okay, and like I said, it's a lot easier to do it if you can actually picture what the graph is. Then you can do the vertical line test in your head. All right, so what about this one? Well, this one's a little tougher. I mean, you know, just to show you, I mean, if I plug, I don't know, let's just say that I plug in 1 for x. So I'm going to get y equals 1 squared minus 3 times 1 plus 2. So y is equal to 1 minus 3 plus 2, which that's going to give me y is equal to 0. Okay? And, you know, I mean, is there a possibility of me getting two different y values? Well, no. See, I can plug in, let's plug in 2. So I get 2 squared minus 3 times 2 plus 2, which that's y equals 4 minus 6 plus 2. And so, well, that's actually 0 also, isn't it? Okay. So I'm not getting two different y values. And let's look at this. Let's even go for a different number. Let's plug 3 in. Y equals 3 squared minus 3 times 3 plus 2, which that's 9 minus 9 plus 2, which that equals 2. Okay, so you see, whenever I plug in an x value, I'm only getting one y value as an answer. Okay, see, like this, y equals this number. It's not equaling plus or minus that number or anything like that. Okay, and just like before, when I plugged in 1, what did I get? I got 0. When I plugged in 2, what did I get? I got 0. So that right there might confuse you. So remember, when we plugged 1 in for x, what did we get for y? 0. When we plugged in 2 for x, what did we get for y? 0. And when we plugged in 3 for x, what did I get? I got 2. And I mean, you can go on and on with this, but you can see, don't let getting the same y, don't let that confuse you. The rule is you can't have the same x value with two different y values. And you can see none of these are the same x value. Okay? So that would make this one a function. Now, these quadratic equations, they're a little more difficult to, you know, I mean, not really once you know what their graph looks like, but just looking at it like this, it's a little more difficult. But like for a parabola, and let me not even draw that, but a parabola, remember when the x term is squared, a parabola looks like this. It's that U-shaped. And so you can see that would pass the vertical line test, so you would know that's a function. Okay. Now on these, I'm going to go ahead and say, okay, let's think about the graph here. Okay, let's think about the graph, and I'm going to also work this one like I did these up here. So that might clear this one up some more too, if you're still kind of confused about that previous example. So in a lot of college algebra books, you've already gone over graphing circles. So you should recognize that this is the graph of a circle. And what does a circle look like? It looks like that. and that fails the the vertical line test, so we know this is not a function. Okay, so that one's easier than the first two. Okay, and that just goes to show what I was talking about. You know, on this one, yeah, we probably don't know what the graph of that looks like, and we probably don't know what the graph of this looks like either. Okay, but you can see when we do know what the graph looks like, we can know, okay, well, that's a circle. Draw my circle. There's the vertical line. It fails the vertical line test, so it's not a function. But the other thing I can do, I can just real quick, let's just pick a value for x. So what if I want to plug 0 in for x? Okay, so that's going to give me y squared equals 1. So y equals what? Plus or minus 1. Okay, you see that? Because what happens, I know that 1 squared, see, I'm plugging in the positive 1 for y, so 1 squared is 1, and then I'm going to plug the negative 1 in for y, so negative 1 squared is equal to 1. Okay, so what happened here is my x coordinate was 0, and then I calculated my y coordinate to be 1, and then also when x was 0, I calculated my y coordinate to be negative 1. And now you can see I got the same x value with two different y values. So this one's not a function. Now this one, in a college algebra class, you've already covered graphing lines, okay, by the time that you've gotten to this section. So, I mean, this is a line, and we know it's a line that looks like, you know, something like that, or something like that. We know it's not vertical because remember, a vertical line is x equals a number. Okay, so if we look at this, we know this is just a line, so we just draw a line anywhere like that, and it passes the vertical line test, so we know that this one is a function. Okay, and so that one would be a function. All right. So like I said, you know, you're just going to have to go through and you'll have to practice these. These are quite a bit more difficult than the first two examples that we looked at. All right, so now let's look at domain and range. It says a relation is a set of ordered pairs. Okay, we looked at the relations earlier. That's when we had this, determine if the relation represents a function. Okay, so we're going to return back to relations as a set of ordered pairs. The domain of a relation is the set of all first coordinates of the ordered pairs, and the range of a relation is the set of all second coordinates of the ordered pairs. All right. Now, we've got some examples here. So state the domain and range of each relation and whether the relation is a function. Variables represent real numbers only. All right. So what happens is when you're talking about domain and range, let's just look at some random function. Let's just look at y equals x plus 1. Okay, forget about all these problems right now that we have. So I can plug values in for x, right? Okay, I can plug in values for x. And then once I plug those values in, I can evaluate the x values and get y values as my answer. Okay, so we plug a number in. So say like we plug 1 in for x, y equals 1 plus 1, which is 2. Okay, or I can plug in 2 for x, so 2 plus 1 equals 3. So the numbers here that I'm plugging in, that's part of my domain. That's the numbers I plug in for x. And then these numbers here, that's the numbers that these functions spit out after I evaluate them. These numbers are members of the range. So the domain, that's the numbers you plug in for x. The range, that's the numbers or the answers you get out for y. Okay? So the domain, that's the x values, and the range is your y values. All right? So let's go ahead and look at this first example. So they want us to state the domain. So this one, we have a relation. We have a set of ordered pairs. All right? And they want me to state the domain. Well, just like it said up here, the domain of a relation is the set of all first coordinates. The range is the set of all second coordinates. So the domain would just be -1, 3. It's all the x coordinates. That's the domain. And see, the 3 appears twice, but we only use it once. And then the range is all the y coordinates. Well, 1, 9, and -9. That's your y coordinate. So -9, 1, and 9. And so there's your range. It's all the y values. And notice I put them in order. You don't have to put them in order, but it does make it, I think it's good to keep it organized. Okay, so, if at all possible, list the elements of your domain and range in order, from smallest to largest. So that's domain and range. And then they also want us to and determine whether the relation is a function. Well, you can see here, see how we got the same x value with two different y values? So this one is not a function. Okay. All right, so what about this one? Let's look at domain and range. Okay, so remember the domain, that's all the numbers that we can plug in for x. Okay, that's our domain. Now, so what we've got to do is see, okay, what all numbers can I plug in for x? What all numbers can I plug in for x? Well, is it okay if I plug 0 in for x? Okay, is that okay to do that? If I plug 0 in, 0 plus 3 is 3. So plugging 0 in, that didn't violate any math rules or anything like that. I didn't get like a 0 in the denominator or anything like that. So it's okay to plug 0 in because there's nothing wrong with doing 0 plus 3. Okay? Now, what about the positive numbers? Is it okay to plug a positive number in here? Well, if I take, let's just think of any positive number you want and add 3 to it. Is there anything wrong with doing that? No, that's fine. I can do any positive number plus 3. 10 plus 3, 1,000,000 plus 3. Nothing wrong with that. Now, what about the negative numbers? Can I plug any negative number I want to in there? Well, sure. A negative number plus 3, there's nothing wrong with that. Just think -5 plus 3. That's what, -2. What about -1 billion plus 3? There's nothing wrong with that either, is it? And so the domain here, that would be what? All the real numbers, -infinity to +infinity. There's my domain. So now, what about the range? Well, the range, that's the numbers we're going to get out, okay? So if I plug in positive numbers, I'm going to get values out, right? If I plug in numbers from 0 to infinity in here, I'm going to get answers from 0 to infinity. And if I plug in numbers from 0 back to -infinity, what am I going to get out as an answer? Well, if I got a number way out there at -infinity and I just subtract 3 from it, that's still a number way out there at -infinity. So my range, I'm going to get all real numbers. That would be -infinity to infinity. All right. Now, let's look at this next one. Y equals x squared plus 8. So, and then also we've got to determine if this is a function or not. So, is it a function? Well, we saw from up here that, the equation of a line, we know what the equation of a line looks like. Okay, so we know that's going to pass the vertical line test, so this one is a function. All right. Now, what about this one? So y equals x squared plus 8. Well, let's go ahead and get the domain. All right, so let's go through the same process, the same thought process for the domain as we did in the previous one, this line here. Okay, so is it okay to put 0 in? Can I square 0? Yes. Well, 0 squared is 0, and then can I add 8 to it? Sure. Now, what about positive numbers? Is it okay to do that? Plug in a positive number? Can you think of a positive number that you can't square? No, you can square any positive number, can't you? And then it's okay to add 8 to it also. So we're good there. And then it's also okay to square any negative number. Okay? So we can square any negative number and then add 8 to it. There's nothing wrong with that. So the domain would be negative infinity to positive infinity. And now we need the range. So let's take a look at this. So I can plug in any number, any x value I want to. So I need to know what values am I going to get out. Well, the values that I'm going to get out is from 8 to infinity. I'm just going to write it down and then I'm going to explain it. All right, so there's my range. And let me show you how we come to that. All right, so if I take 0 and plug it in for x, I'm going to get 8 as an answer, right? Okay. And then I'm going to take 2 and plug it in for x. And that's going to be 4 plus 8 is 12. And then I'm going to take negative 2 and plug it in. Well, negative 2 squared is 4 plus 8, which is 12 also. And then we can do the same thing if we plug in 1. That's going to be 9, and then plug in the negative 1. That's going to be 9 also. Okay, so hopefully you can see that no matter what value I plug in for x, I'm never going to get a number smaller than 8. Whether that x value is positive or negative, that doesn't matter, because the x value that I'm plugging in, you see that? I'm squaring it. Okay, and anytime you square a number, you get a positive, and then I'm adding 8 to it. So if you take any number, any positive number, and add 8 to it, that number is going to be larger than 8. But I can also see that when I plug the x value of 0 in there, that's going to give me 8. This is going to be the smallest y value I can possibly get. Okay, and so that's why our range is 8 to infinity. And then as far as is this a function or not, well, we kind of went over that in the previous example where we had that quadratic, and so we know this one is a function. Okay, if you have y equals and then x squared and some other stuff, that's going to be a function. There are parabolas that are not functions, but that's when the y term is squared. Okay. All right. So let's look at this one. Y equals the square root of x plus 3. All right. So in the previous problems, I've said, okay, can we plug 0 in? Can we plug positive numbers in? Can we plug negative numbers in? And that's how we determine the domain. Well, with square roots, I mean, you can do that, but there's an easier way to do it. So the way that we want to look at square roots is Look at that. And do you agree with me that what's underneath the square root, whatever we have under here, can't be negative? We can't take the square root of a negative number, okay? You saw that in the lesson on complex numbers. Remember, if you had, say, like the square root of -4, that was what? 2i. Remember that negative square root of -1 is I, okay? So, I mean, you can take the square root of a negative number, but you get an imaginary number as a result. So, and when we're talking about domain and range, we're looking at the real numbers, not the imaginary numbers. So, so you agree that, hopefully you agree now, that what's underneath the square root cannot be negative. So that means this x plus 3 that is underneath the square root has to be larger than 0, right? Because any number larger than 0 is positive, okay? Now, let me ask you this. Is it okay for it to be equal to 0? Okay. Can we take the square root of 0? Well, let's see. Square root of 0, what's the square root of 0? It's 0, okay? So that's right. Whatever's underneath this radical here has to be larger than 0, or it can equal 0, all right? And by this time in your college algebra class, you've learned how to solve inequalities. So I'll subtract 3 to both sides. And so I have x is greater than or equal to -3. So my domain, well, that's everything greater than or equal to -3. So that's everything from -3 to infinity. And is the -3 included? Yes. So it's going to have a bracket on it. And then, as always, we put the parenthesis on the infinity. Now I need the range. All right. Now, whenever I take the square root of a number, okay, I take the square root of a number. Well, the square root of a number is always positive, okay? Think back to the lesson where you learned about square roots, okay? And this symbol here represents the principal root. And what's the principal root? It's the positive one, okay? So the square root of something is going to always be positive, okay? Can it equal 0? Yes. Well, I mean, we showed that just a while ago. The square root of 0 is 0, okay? So our answers that we're going to get out, we can get 0 as an answer, and then positive numbers. So that's everything from 0 to infinity, and we can get 0, so the 0 is included, and then we put a parenthesis there, okay? Now, is this a function or not? Well, yes, it's a function, because if we take, let's say we take y equals the square root, and let's just plug 1 in for x. Then y equals the square root of 4, which that's 2. Can we get 2 different values for y? No, it's just 2. It's not plus or minus 2, it's just 2. Okay? So for any x value we plug in, whether it's 1, 2, 3, 4, 5, 6, or whatever that's in the domain, we're only going to get one answer for y. And so there's no way we can have the same x value with 2 different y values. So this one is a function. And then once you learn how to graph these things, you'll be able to see even easier. The graph of this one looks something like this. Okay, this right here, that's another lesson of when you graph functions and stuff. So don't worry about how I got this. That's in a later lesson. Okay, so but yeah, that's the graph of it. But this is how we'll need to think about it right now. Okay. All right, so let's see what we've got here. All right, so So now we're going to look at function notation. All right, so we've got let h equal this relation, this set of ordered pairs, and f of x equal the square root of x minus 3. Find each of the following. All right, so first we're going to be basically what this is evaluating functions. So this is what we're doing here. Okay, we've got h, so all we're working with now is this function h, and then I've got two examples where we work with the other function f of x. All right, so right now we've got h of 7. That's what they want us to find. So what they're saying is when the x value is 7, what is the y value? So you can see here when I'm sorry, I said x value. Evidently, this is w. They're using w. And that might be kind of confusing. So let me just change this problem up. Let me just put x here and x here so it don't confuse you. In other words, this right here can be anything. Okay. If it's a w, it's just that w is acting like your x value. Okay. But let's just change it to x to avoid any confusion right now. All right, so we've got h of 7. So when your x value is 7, what's your y value? Well, we can see up here when x is 7, what's y? It's 9. And so this equals 9. And that's your answer. All right. Now, what about this one? This time they want us to find x if h of x is 0. So what does this mean? Well, this means, okay, h of x, and keep in mind, this is the same thing as if I wrote y equals 0. It's just a different way to write it. In other words, you can write y equals 2x plus 1, okay? You've seen this before. This is familiar to you. Writing your equation like this, y equals. I could also write f of x equals 2x plus 1. I can write h of x equals 2x plus 1. I can write g of x equals 2x plus 1. K of x equals 2x plus 1. Every one of these mean the same thing, okay? It's just that instead of using a y, I used f of x, or I use a h of x, or a g of x, or a k of x. It's the same thing. This right here does not mean f times x. This right here is just like saying y equals 2x plus 1. This is function notation. This is just a different way to represent it, okay? And it comes in handy if you're dealing with a bunch of functions. You see how if I have, if I'm dealing with more than one function and I need to represent them, well, I can write f of x equals x plus 3 and g of x equals 2x minus 1. Okay, so there it is. Well, what if I used y all the time? If I just use y? Well, that don't look right because it's saying y is equal to two different things. But this is just a way to label the functions different. Okay? All right. So just remember f of x, h of x, g of x, whatever, that's the same thing as y equals. Okay? So what they're wanting to know here is when y is equal to 0, they want to know what is x. So when y is equal to 0, my x value is 6. So x equal 6. And there's my answer. Okay? All right, let me move this up. That way we can see f. All right. So here they want us to find f of 7. Well, we know that f of x equals, and I'm going to go ahead and just write it down, f of x equals the square root of x minus 3. All right? And they want us to find f of 7. So what they're wanting us to do here is take this 7 and see we're just replacing the x with the 7. That's all we're doing. So I get f of 7 is equal to the square root of 7 minus 3. Okay, I replaced all the x's with 7's. And so this is the square root of 4, which equals 2. And there's your answer. All right. So let's just write the function down again so we can see it. All right. So now they're wanting to know when f of x is equal to 5, what is x? So f of x is equal to 5. So I'm going to replace this f of x with 5. See, it's telling me f of x is 5, so I'm just going to replace it. So that's 5 equals square root of x minus 3. And then I just solve for x. So to do that, I need to what? I need to square both sides. And so that's going to give me 25 equals x minus 3. And then I will add the 3 to both sides. And so that's going to be x is equal to 28. And so that's the x value. All right. Okay, so we've got some more problems here. Given that f of x equals x squared minus 2 and g of x is equal to 2x minus 3, find and simplify each of the following expressions. All right, so, well, I mean, this is exactly what we did last time in the previous example, except it looks like instead of plugging numbers in, we're actually just plugging variables in, okay? So I'm going to go ahead and let's see. Let's just write the function. Let's write our function here. Okay. So I just rewrote the function. Okay. This is not part of working the problem. And I guess since I rewrote it there, let's write it in a different color. Let's write it f of x equals x squared minus 2. All right, so this is I think this will let you see better of what's going on. So when I look at this, I want to find f of a. So all this is doing is telling me to take the a and plug it in for x. And so this is this is plug the a in for x. So that's a, and then it's squared minus 2, and that's your answer. There's nothing else to simplify. Okay. All right, let's look at the next one. I'm going to go ahead and just write the function down again. Okay. So in this problem, it's asking me to take the a plus 1, right? See, whatever's in parentheses, you're going to put that in for x. Okay, now like I said, what I've written here in red, just writing the function down below it, that's not part of the problem. But if it helps you to see it better, then by all means do it. Okay, so this is equal to, now the a plus 1, that's getting plugged in for x. So that's a plus 1, and then that's squared. So the whole thing's squared minus 2. And then they want us to simplify, okay? So this is going to be what? A squared plus 2a plus 1. Okay, so what I did there is this is a plus 1 times a plus 1. That's this a plus 1 squared. If I write it out as a plus 1 times a plus 1, and then I FOIL it out, and that gives me this right here, okay? And then that's minus 2. And so combine like terms, a squared plus 2a minus 1. And there's my answer. All right, let's look at this one. I'm going to move this up in case we need more room. All right. So let's see what we've got here. So we've got f of x is equal to x squared minus, now let me write that in red. We've got f of x equals x squared minus 2. All right. Now, this has two parts of it. This is f of x plus h, and then minus f of x. So let's just look at this first one. Okay, let's take care of that one. So I'm going to take the x plus h, and I'm going to plug it in for x. And so that's going to give me x plus h, and then that's squared, and then minus 2. All right. So that's this part. That's this. This is f of x plus h. All right. And then I've got to do minus, see the minus, f of x. Well, what's f of x? Well, it actually just tells us f of x is this. And, or I mean, if you did replace it, look, if I just took the x and put it in the place of x, I just get the same thing back. So that's minus x squared minus 2. And this is f of x. That's this f of x right here. Okay. Now, hopefully you're sitting there questioning me about this, saying you did that wrong. You didn't write that correctly. And I didn't. And I want you to think for a minute, how did I not write that correctly? What's wrong with it? Well, it's minus f of x. See, this whole thing is f of x, so this has to be in parentheses. Do not forget the parentheses. Okay? So now, well, let's FOIL this out, just like we did the a plus 1 squared up here. So let's FOIL that out. And, distribute this, clear the parentheses, and combine like terms because they want us to simplify it. So this is x squared plus 2xh plus h squared. Okay. If you need to, write this out as x plus h times x plus h and FOIL it out if you need to. That's this part right here. And then I've got minus 2. And then remember, this is like a negative 1. I'm going to distribute the negative 1. So minus x squared plus 2. And so this is equal to, well, look, x squared minus x squared. Those go out to 0. Negative 2 plus 2. Those go to 0. And so I'm just left with 2xh plus h squared, and there's my answer. Okay. All right. So now let's see what we've got. Now we're at g, function g, and let's go back up here. I forgot what g is. It's 2x minus 3. 2x minus 3. So g of x is equal to 2x minus 3. Okay. So let's take a look at this one. All right, so, I mean, it's the same thing, okay? It's the same thing. We're going to take the x minus 2, and we're going to plug it in for x. So this is going to be 2 times x. Well, what are we putting in the place of x? X minus 2. So 2 times x minus 2, and then minus 3. Minus 3. All right. And then we clear the parentheses. That's going to be 2x minus 4. And that's that. And then minus 3. So that's going to be 2x minus 7. And there's your answer. All right. All right, the next one. Let's go ahead. Let's move this up a little bit closer. All right, let's write our function g down. So g of x equals 2x minus 3. And like I said, writing this down, that's not part of the solution. It just, I think sometimes it might help you. All right, so, well, this one's going to be just like this one we did up here, where we got to do it in 2 parts. All right. So let's look at this one first. So I'm going to take the x plus h and I'm going to plug it in for x. And so that's going to be 2 times, and then in the place of x, I'm going to put x plus h, and then minus 3. Okay, so that's this part. That's this. Let me do it a little bit different color. So this is g of x plus h. All right, and then I've got minus g of x. And what's g of x? That's 2x minus 3. And we learned from earlier that has to be in parentheses because it's minus the whole thing. And this is your f of x. Okay. Now let's clear the parentheses and combine like terms. So that's going to give me 2x plus 2h, distribute the 2, minus 3, distribute the negative 1, minus 2x plus 3. And then you can see 2x minus 2x is 0, negative 3 plus negative 3 plus 3 is 0. And so I'm just left with 2h. And that's my answer there. All right. All right, so what about this? If x1, y1 and x2, y2 are two ordered pairs of a function, we define the average rate of change of the function as x varies from x1 to x2 as the change in y coordinates divided by the change in x coordinates. So this is the change of y over the change of it. Well, or let's just look at this one. The change in y over the change in x is equal to y2 minus y1 over x2 minus x1. And this right here is just the delta symbol. It's like a triangle. That just means the change in y. So the change in y over the change in x. And this right here is pretty important. You'll see this as when you're looking at, or you may recognize it from slope. Okay, slope of a line. So for this example here, let's just take a look at it. It is asking us, what is the average rate of change f of x equals x squared on 1 to 3? Okay, on 1 to 3. So they didn't come out and give us 2 points and say, what's the average rate of change? They want to know the average rate of change from 1 to 3. From x equal 1 to x equal 3. These are x values here. Okay? So we've got the x values. We want to know the rate of change from 1 to 3. But notice we don't have any y values. But we can get f of 1. Okay, remember y and f of x, that means the same thing. Okay, it would be the same problem if it was written like that. Okay. All right, so if I plug 1 in for x, that's 1 squared, which equals 1. If I plug 3 in for x, that's f of 3 is equal to 3 squared, which equals 9. So basically what I have is I have the point 1. See, x was 1. And what did I get for y? I got 1. And I plugged in 3 for x, this 3 here. And what did I get for y? 9. Okay, so I want to know the average rate of change from this point to this point. Okay, so here's my x1, y1. Here's my x2, y2. And so the average rate of change is equal to what? This, y2 minus y1 y2 minus y1 over what? x2 minus x1. x2 minus x1. And so that's 8 over 2, which equals 4. And that's your average rate of change. All right. Now, let's look at this. We have the difference quotient. So the difference quotient is the expression f of x plus h minus f of x, all that divided by h. And we want to calculate this difference quotient. Okay, we want to calculate the difference quotient. So it says find and simplify the difference quotient for each of the following functions. So what they're wanting us to do is they're wanting us to find f of x plus h minus f of x, all that divided by h. They're wanting us to calculate that for this function here. Okay? So, look at this. Doesn't that look just like two of the examples we just worked? You see that? Isn't that that? And this. You see that? It's the same thing. The only difference what we're doing is we're putting an h underneath it. Okay? So, let's go ahead and work this one. So this is what I'm wanting to calculate. All right? So right now, just forget about the h down there. Okay? And as a matter of fact, let's just erase it right now. Okay? We're going to put it back, but just for plugging this in. So remember what we did before. The x plus h, I'm going to put that in the place of x. So that's going to be 3 times x plus h plus 2. There's my f of x plus h, right? I just replaced the x with x plus h. Minus f of x, so minus this. So the 3x plus 2 needs to be in parentheses. Okay, so hopefully that makes sense. We worked, like I said, we worked two of those just a while ago doing that. Now, what's the only difference with this difference quotient? It's got an h underneath it. And that's all we do. We just put the h underneath it. All right. Now, what we have to do is simplify this thing. We have to simplify it. And what we're doing to simplify this thing is we want to cancel this h out of the denominator. That's what we're wanting to do. Okay. If you have to take any more math classes like calculus, you're going to see this again. This is going to be one of the first things you do in calculus. And what happens in calculus is we're going to plug 0 in for h. Okay. I'm not going to get into the details of it, but you're going to be plugging 0 in for h. And you know if you have 0 in the denominator of a fraction, it's undefined. So we want to cancel that h out. Okay, like I said, you'll see that if you're in something where you have to take calculus. It's in the first calculus class, or if you're in some other kind of major and you want to take calculus as an elective, you could do that. Okay. All right, so let's go ahead and simplify it. So all we're going to do is clear the parentheses. So that's what? 3x plus 3h plus 2. So all I did was distribute the 3. And then I'm going to distribute the negative 1. So minus 3x minus 2 and all that over h. And so let's see, combine like terms in the numerator. 3x minus 3x is 0. 2 minus 2 is 0. And so I'm left with 3h over h. And look how nice that works out. The h's cancel out. And so I'm left with 3 as my answer. See, that's not too bad. Let's look at another one. We've got, let's see how many. Okay, so we got a few more, don't we? All right. Same thing. So let's do f of x plus h minus f of x, all that over h. All right. So just like before, all the x's, let's replace them with x plus h. So that's x plus h squared plus 2 times x plus h minus 3. So all I did, this x and this x, I replaced with x plus h. Okay, so this first term here is my f of x plus h. And then minus f of x. Well, what's f of x? That's x squared plus 2x minus 3. And it's minus the whole thing, so that needs to be in parentheses. And that's all over h. All right, so now let's multiply, distribute, multiply, combine like terms. Okay, so remember this first term is the same thing as x plus h times x plus h. You'll FOIL that out, and you'll get x squared plus 2xh plus h squared. Okay, that's this part is this. And then I'm going to distribute the 2. So plus 2x plus 2h minus 3. And then I'm going to distribute the negative. So minus x squared minus 2x plus 3. And all this over h. All right. So now let's see how this thing simplifies. So the x squared minus x squared is 0. I've got 2x minus 2x is 0. And I've got negative 3 plus 3 is 0. And so I'm left with 2xh plus h squared plus 2h. And that's it over h. And this is equal. All right, so remember what I said, when you're simplifying this thing, you want to get that h out of the denominator. Okay, so you can see here how I have a common factor of h. I can factor that out. So that's h times 2x plus h plus 2, all that over h. And then the h's cancel out, and so I'm left with 2x plus h plus 2. All right, we only have two more examples to do. If you've come this far, don't stop now. Just hang in there till the end. All right, so now we've got square root. And so I want to find f of x plus h minus f of x, all that over h. Okay. All right, so let's see what we get. So I'm going to take the x plus h and plug it in. I'm going to take the x plus h and plug it in for x. So that's the square root of x plus h. See, I just replaced the x with x plus h. And then minus f of x. Well, what's f of x? It's the square root of x. And all that over h. All right. Now remember what I said. We have got to get that h out of the denominator. That's what we need to do. And how in the world are we going to do that? Well, this right here takes you back to, remember when you had something like this and you had to rationalize denominator? What'd you do? Multiply numerator and denominator by the conjugate of the denominator. We rationalize the denominator. Okay. Well, here we're going to rationalize the numerator. So I'm going to multiply numerator and denominator by the conjugate of the numerator. All right. So also, if you remember, this is in the form a minus b times a plus b, which is a squared minus b squared. All right. And we can see in this problem, a is the square root of x plus h. B is the square root of x. And so this is going to be the square root of x plus h squared minus the square root of b squared, which is square root of x squared, over h times this, square root of x plus h plus the square root of x. All right. And then remember, whenever you square a square root, your answer is just what's underneath the square root. So this squared is x plus h minus, and then this squared is x, and that's over h times square root of x plus h plus square root of x. And then, well, this works out nice, doesn't it? The x's cancel out. Come down here and do it. That's going to be h over h times the square root of x plus h plus the square root of x. And then you can see here the h's cancel, and I'm left with 1 over the square root of x plus h plus the square root of x. And there's your answer. All right, last one. Let's see what we got. So we want to calculate the difference quotient. All right, so what are we going to do? We're going to replace x with x plus h. So that's going to be 5 over x plus h. Okay, there's my f of x plus h. I just replaced the x with x plus h, and then I've got minus f of x. Well, what's f of x? It's 5 over x. And then all of this over h. All right, so like I said, you're in college algebra. This part, simplifying this, you've done this before, in college algebra. This is just simplifying a complex fraction. Remember, we can look at this as being h over 1. And so remember, you get the common denominator of all these denominators. So the common denominator is x times x plus h. And what do we do with that common denominator? We multiply it to each term. So I take the common denominator, multiply it to each term. And then that's going to be h times x plus h. Okay? So all I did is I multiplied each term by the common denominator. Look, this might let you see it a little better if I do this. Let me do this. So basically all I did, I just wrote the common denominator next to each term. That's all I did for this. Okay? And then look what happens. See here, the x plus h's cancel. Here the x's cancel. And so I am left with, what is that? 5x minus 5 times x plus h over h times x plus h. Now remember, what we're trying to do is we're trying to get this h out of the denominator, which that's this one right here. So this is going to give me 5x, and then I distribute minus 5x minus h. Nope, I'm sorry. Minus 5h over h times x plus h. And then what happens here? The 5x's cancel out, so I'm left with negative 5h over h times x plus h. And then the h's cancel out, and so I'm left with negative 5 over x times x plus h. And yes, if you wanted to, and I don't know how you'll see an answer in the book, how they write it, but a lot of times you might just see this. You see the difference in the way I wrote the solutions? I just wrote the negative out in front instead of in the numerator. I mean, either one is acceptable. It doesn't matter. Just remember, negative a over b is equal to a over negative b, which is equal to negative a over b. It doesn't matter where you have the negative sign. Okay? So, I hope you feel smarter now. Hope everything made sense. Like I said, I know this was a long section, but check out my other videos. Give me a like, share, and subscribe, and thanks for watching.